All right, so here we go, starting on Unit 4. And Unit 4 is going to cover polynomials and rational functions. There is a lot of information in this unit, and this could take us almost to the end of the semester. So we've decided to break this up a little bit. We're going to actually have 3 different sections. So we're going to start off with polynomial functions and equations and do some long divisions and synthetic division. So all of these parts right here will be kind of like a little mini unit, and then we're going to have a test on these first 3 sections. And then we're going to look again at another part of this, and this is real zeros of polynomial functions and complex zeros. And then we're going to have another test on just these 2 sections. And then at the end of this unit, we look at just rational functions, and then we will have another test. So we're just going to kind of break this up and do this pieces at a time. So starting off with polynomial functions, and I'm sorry, this is going to be a long section. So a polynomial function is a series of terms with coefficients, and x is raised to positive integer powers. Okay, so in terms of a series of terms, in higher level math classes, we could start off with, here's a coefficient, a sub n. This is like our first coefficient, times x to a power n plus a sub n minus 1. So this is our next coefficient and our next power. And we would keep going with that until we got to a coefficient times x to the first power plus just a coefficient. And we could say that this is x to the 0 power, but we know this is just 1. So this term here is just a constant term because it's a number times 1, and that would be our constant. So these powers of x must be positive, so you can not have negative coefficients, and they have to be greater than or equal to 0. So we're just looking at integers that are positive. So we can start at 0, 1, 2, 3, 4, 5, 6, 7, 8, however many degrees, keyword here, degrees, that we need to go, and however many terms we need. So in example 1, it says to determine which of the following functions are polynomials and state the degree. Now the degree of a polynomial is the highest exponent. Okay, so the highest exponent that we see. So in part A, we see 2 minus 3x to the 4th. All of our exponents are positive integers, or a 0 power right here, and my highest exponent is 4. So this is a polynomial, and the degree is 4. That's the highest exponent right here. Now this one, on part B, the square root of a number is the same thing as x to the 1/2 power. And because my exponent is not an integer, this is not a polynomial. Here, you can't have any type of fractions. You can't have your x parts being a fraction. You can't factor this out and cancel factors. So this is not a polynomial. Now this one is f of x equals 0, and 0 is just a constant. So that would be like saying 0 times x to the 0 power, which would be 0. And this is a polynomial, and this degree is 0. This one is also a constant. So this is like saying 8 times x to the 0 power, where x to the 0 power is 1. So this is just 8. And this is a polynomial with degree of 0 as well. Now this over here is an expression that we could actually multiply this out. So if I were to do FOIL here, I would have negative 2x to the third times x. So this would be negative 2x to the fourth. And then negative 2x to the third. Oops, I didn't see that square here. I'm going to cancel that. And I have x minus 1 squared. So that would be, sorry about that, x minus 1, that would be x squared minus 2x plus 1. I didn't see that there. And then multiply that by negative 2x to the third and do the distributive property on this one. I'm going to have negative 2x to the fifth power, and this would be plus 4x to the fourth power, and then minus 2x to the third power. So this is also a polynomial, and my degree on this one is the highest exponent, which is 5. So we have some special names for some polynomials. If it is a 0 degree, I mentioned above, it's a constant. Okay. And the graph of a 0 degree polynomial or a constant is just going to be a horizontal line. First degree is linear. If I have something x to the first power, and this one is going to be some kind of line, depending on if it is a positive or a negative coefficient of x. And a second degree is going to be a quadratic. And we know we have some form of u. I could also put in a third degree, which would be cubic. And a cubic function, if you remember, is like a chair. All right, so just a little bit of a review there. One thing, polynomials, if we look at the graphs, and I just kind of put some pre-writing in here, all polynomials are going to be smooth graphs and they're going to be continuous. Now what that means is there can be no corners in your graph. So if I look at a graph like this, which is an absolute value looking type of graph, this is not a polynomial. The absolute value of x is not a polynomial function. And that would be because of we have this corner inside here. There can't be any breaks in the function, anything like this. You can't have any holes in a function in your graph, and it can't jump. Like if you had a graph that did something like that. Everything has to be smooth, and it has to be continuous. Everything has to be smooth and connecting. The next thing we have down here is a power function. And a power function is a monomial. Okay, so monomial. And that means it has one term. And most often we write that monomial as a x to some power. A cannot equal 0 because if we have 0 here, this would be a constant. And n has to be greater than 0 because if this were 0, it would be a constant. And if it were negative, it wouldn't be a polynomial. So some examples of monomials are like 3x. Okay, so here's a monomial and my power is degree 1. How about negative 5x squared? This is a monomial, one term, and this is degree 2. Okay, I could have a coefficient be a fraction. Okay, so my coefficient can be a fraction, but my exponent cannot. Okay, so this is degree 4. All right, so these are just some examples of monomials. Now, if we're looking at the graphs of different types of power functions, there are some things that are in common. All right, so we have some properties here. Power functions can be even or odd functions, and it has to do with the exponent. If the exponent is even, like x to the 4th, then this is an even power function because our exponent is even. Now, we talked about even functions prior to this, and if we remember, even functions are symmetric over the x-axis. Okay. The domain is always all real numbers, and the range is greater than 0. So if I were to look at a power function, make a little graph here, I'm always, let me get to this next part first. The graph always contains the points 0, 0, 1, 1, and negative 1, 1. Okay, no matter what the exponent is, I'm always going to have these 3 points on my graph. So here's 0, 0, here's 1, 1, and here's negative 1, 1. So it's going to kind of come down and hit the axis and bounce up like that. So as my exponent gets bigger, if I get x squared, x to the 4th, x to the 6th or 8th, my graph is going to go up faster. So if this is x squared right here, this might be x to the 6th power. Okay, it's just, whoops, sorry, it has to go through these points. Always goes through those points. So this could be x to the 6th hour. It's just going to go up faster after you pass the x values of 1 and negative 1. All right, so then we have some properties of odd integers. And an odd integer, like x to the 1st, x to the 3rd, x to the 5th, is going to be an odd function. That means it's symmetric over the origin. Okay. And if I look at just like the x to the 3rd function, if I look at a cubic function, these graphs are also going to contain the same points of 0, 0, 1, negative 1, negative 1 down here, and 1, 1. So it's going to come up, hit 1, 1, and then go up again. Okay, my domain will be all real numbers, and in this case, my range is going to be all real numbers. And that's because I have negative y values and I have positive y values. In the even power functions, my range is always going to be greater than or equal to 0 because I'm not going to go below x-axis unless it's some kind of transformation, like if it has a +1 at the end or -1 at the end. All right. And as our exponents get larger, the graph is going to get skinnier. So I said this was like an x to the third function. If I were to make an x to the fifth function, it's just going to go up faster and it's going to get skinnier. So down on the bottom, it's asking us to graph some transformations, or graph some power functions and transformations of those. So this first one, we have an even function, and it's going to be shifted to the right 1 unit, and it's going to kind of go up a little fatter, just like it was when we were looking at quadratics, okay, or absolute values. All right, so I'm going to have a u. My vertex is going to shift to the right 1 unit, and the 1/2 is going to make it fat. All right, so it might look something like this. The next one is a power function. It's odd, so it's going to take on this shape of the chair function, and instead of going through the origin, we're going to move it down 3. So it's going to go down, or go up, hit 3, and then turn the corner and start going up. If I have negative x to the 7th power, this is going to be odd. Okay, so it's going to look like this, except for we're going to flip it over the origin. I'm sorry, flip it over the x-axis. So instead of going up and then turn the corner, we're actually going to come down, turn the corner, and then go back down. Okay, that's just a reflection. Now on this last one, we have a couple things going on here. We have a shift. This 4 means I'm going to go up 4. And I'm going to have, this is an even function, so it's going to be a u, and it's going to shift to the right 4, or right 2. And the negative means it's going to flip. All right, so first I'm going to find my vertex where I go up 4 over 2. So here's my vertex. It's going to go down and kind of turn this way. All right, so just some simple graphs of power functions where we're looking to see if it's an odd or an even function, okay, and just taking those shapes and shifting them based on the transformations that are given. All right, moving along. In the next part, we are going to look at zeros, identifying real zeros and their multiplicity. So here's a definition. It says, if f is a function and r is a real number for which f of r equals 0, then r is called a real zero of f. Okay, so r is a 0 of x. Now, we use this word a 0 interchangeably to recognize intercepts. Okay, so these are actually x-intercepts. and we also call them roots. So if I know what the zeros are, I can find factors by taking my 0 and subtracting it from x. So x minus r, and r is a root or a 0 or an intercept, but the factor would be that number subtracted from x. So in example 3, it says to find a polynomial of degree 3 whose zeros are -3, 2, and 5. Okay, so degree 3 means we're going to have an x to the third power. And my zeros, 3, 2, and 5, if I make them into factors, I'm going to have x minus -3, so that'd be x plus 3. And then I have x minus 2 and x minus 5. So I take each one of these zeros and make it a factor. Now if this said 0 over here and we were solving for x, I'd say x plus 3 equals 0, and my 0 would be -3. All right, so we're working backwards right now. So what I need to do is multiply this out. So we're going to put it we're going to multiply it out and put it like in a standard form. So I'm going to take 2 of these factors, and it doesn't matter which 2 you multiply together. I'm just going to choose these 2. So if I do FOIL here, I'm going to have x squared minus 5x and minus 2x is minus 7x. And then -2 times -5 is plus 10. And I'm going to take this trinomial and multiply it by x plus 3. Okay, so I'm going to distribute again with x plus 3. So I have x times x squared is x to the third power. X times -7x is -7x squared. And x times 10 is plus 10x. Then I have plus 3x squared. So I like to line up my exponents. So I have plus 3x squared. And then 3 times -7 is -21x. And 3 times 10 is 30, positive 30. Now if I add these together and just combine like terms working down, I'm going to have x to the third minus 4x squared minus 11x plus 3. And this would be my polynomial with degree 3. So then it says if the same factor, x minus r, occurs more than once, r is called a repeated or a multiple 0 of x. So that's like saying I have x minus 2 and x minus 2. Okay, so I'm going to have my 0 be 2 and my 0 here be 2. So instead of writing out each 0, I could say I have a 2 as a 0 and the multiplicity is 2. So that means I have 2 factors with 2 as a root. So if I look down here, it says what are the zeros of this polynomial? Now I don't want to multiply this out. The third power of x plus 1/2 would be a real pain to do that. So if I look at this, x plus 1 is a factor, and in this case, my 0 is going to be x equals -1. And that occurs one time. So if it just occurs once, we don't have to specify what the multiplicity is. But notice I have x minus 2 here. and that's squared. So I have two groups of x minus 2. So my 0 here is going to be 2, and it's going to occur 2 times. And then I have a factor of x plus 1/2, and this is to the third power. So I have a 0 of negative 1/2, and that occurs 3 times. Okay. So the multiplicity just tells us how many times that 0 is going to occur. And by being able to identify that, we're going to be able to look at some graphs, and that's going to help us in a few minutes. That's going to help us draw a graph without plotting a whole bunch of points or making a table or anything like that. So in example 5, I have a polynomial, and I want to graph this using the x and y intercepts. All right, just the x and y intercepts. So remember, my x-intercepts are the zeros. And the zeros here, wherever I see an x, I need to find the 0 of that. So here I have a 0, and that occurs 2 times because it's squared. And then I have a minus 2. Or, sorry, the 0 is plus 2. So if I were to graph this, I know that I'm going to have an x-intercept at 0 and at positive 2. Okay, this is 0, this is 2. If I find my y-intercept, my y-intercept happens when x is 0. So if I plug in 0 for x squared, I'm going to get 0, and then 0 minus 2 here. So 0 times anything is just going to be 0, so 0, 0 is my y-intercept. So really what's going to happen here is I'm going to come up here, I'm going to start down low, and I'm going to come up, and I'm going to bounce off the 0 here, and I'll tell you how we know if we bounce off of that in a second. And I'm going to come down and then go up something like this. All right, so how we know if it's going to bounce off this and just turn the corner there, or if it's going to go up and then turn the corner, is if it has to do with the multiplicity. So if our multiplicity is even, the graph is going to bounce, which means it touches the x-axis and turns around. Okay. If I have an odd multiplicity, it's going to pass through that point. And that point is the x-intercept. All right, so that multiplicity will tell us if it will go through the intercept or if it's going to touch the intercept and turn. And we'll do a couple more of these. On to the next page. Told you it was a long section. All right, so this one says to graph the function. All right, so we're going to graph this based on some things that we know. Here, I'm going to first look for my intercepts. So my x-intercepts, I know I'll have a 0 at 0, and that occurs 3 times. I'm going to have an x-intercept at 4, which occurs 1 time, and an x-intercept at -2, which occurs 1 time. So if I go to graph this, and if I just put on here my x-intercepts, so I have -2 here, I have one at 0, and then I have one at 4. Okay. I can also find my y-intercept by plugging in 0 for x. So if I plug in 0 and I cube it, I get 0. And then I have x minus 4 is -4, and then x plus 2 is +2. It doesn't really matter what these are, because if I multiply by 0, I'm going to get 0. So my y-intercept here is going to be 0. But let's use a sign chart like we did before. And if I put my points here, I'm going to have a point at -2, a point at 0, and a point at 4. And if I pick a number that's less than -2 and plug this in here, like -3. Okay, if I plug in -3, and I'm not worried about the number, I'm more worried about just the sign. So if I plug in -3, I'm going to have -3 to the 3rd power is negative. -3 minus 4 is also negative, and -3 plus 2 is also negative. So a negative times a negative times a negative, this section is going to be negative. So that means this area is going to be below the x-axis. Now let's plug in a number that's between 0 and 2, like 1. If I plug in 1, and that would be -1, -1 to the 3rd power is negative. -1 minus 4 is also negative, and -1 plus 2 is positive. So here I have a negative times a negative is a positive, times a positive is positive. So this section is going to be positive. And between 0 and 4, let's pick another number like 1. So if I plug in 1 into my equation, 1 to the 3rd power, that's +1, positive. 1 minus 4 is going to be -3, so that's times a negative. And +1 plus 2 is a positive. So a positive times a negative times a positive is negative. And how about a number bigger than 4, like 5? So +5 to the 3rd power, I know that that's going to be a positive number. 5 minus 4 is positive, and 5 plus 2 is also positive. So bigger than 4 is going to be positive. So what this means here is I'm going to start below -2. So my x values less than 2 are going to come up this way, and it's going to hit 2, and because 2 is there only one time, it's going to go up and through 2. So now it's going into the positive part. Between 0 and -2, I have a positive, and somewhere it's going to turn, and it's going to go back to 0, and 0 again is an odd multiplicity, so it's going to pass through 0, and it's going to go down to where the y values are negative, and it's going to turn the corner, hit 4, which has an odd multiplicity because it has a multiplicity of 1, so it's going to go through. All right, so that is some picture of what this would look like. So then we have turning points. So how many times can my graph turn? So if f is a polynomial function of degree n, then f has at most n minus 1 turning points. So if I look at this right here is degree, and I need to count my x's. So here's 3 x's, another one, and another one, so this is degree 5. So the most turning points that this graph could have is 4. But because when we have multiplicity of, we have more than one factor of the same number, we often will have less turning points. So if we look, I have 1, 2 turning points here. I have one up here and one down here. So these actually, we've thought of these before as maximums and minimums. All right, so local maximums and local minimums, we would have at most 4 local max and mins together. Then the last thing we're going to talk about is end behavior. All right, so end behavior means what happens at the ends of the, I'm circling here, what happens at the ends of the graph, okay? We don't know what's happening in the middle, but the end behavior we can also look at by the degrees. So if I have an even degree polynomial, like x to the 4th power, if my coefficient a is positive, my end behavior is going to come up here and it's going to exit this way. So they're both going to be pointing up. And this is a positive coefficient. If I have a negative coefficient, I'm going to have a graph where it's coming up this way and going back down. So in my graph, it will be going down on both ends. Okay, so even degrees are both up or both down. If I have an odd degree, that means one side of my graph is going to go up and one side is going to go down. So if my coefficient is positive, I'm going to start here and just kind of work like this. So this is x to the 3rd power, okay? And this is 1 times x, this is positive. So my graph will go down this on the left-hand side, and it will end up going up on the right-hand side. And depending on what's happening here, depends on other factors and other zeros we might have. So this is for a positive coefficient. If my coefficient is negative, all right, so if I think about what's happening there, remember if I had negative x to the 3rd, I started this way, it came down, we reflected. If my coefficient is negative, that means I'm going to go up to the left, and then something happens in my function, and then I'm going to go down to the right. So up, then down. All right, and I think I'm going to stop here, and we're going to work on the next page in class.